Hopefully that has actually worked.
Yep, says it's happening.
Okay, and so welcome to Thursday, which is day 3 of relay testing exercises featuring Mr. Krieger. Without further ado, take it away, Mr. Krieger.
Thanks, JB, and thanks again to everybody who hasn't tired of me yet. Come back for the third day of punishment, but I'll get started here by sharing my screen, I hope. And what I would like to do is everyone should be able to see just full a PowerPoint. Is that true?
Yes.
See that? Okay, great. Let me skip through here. We were all here, most of us were here yesterday, and based on some of the feedback that an individual offered, I just wanted to make sure that we were clear on what it is I was doing here. The whole premise of my presentation is geared specifically for education purposes. In fact, the title of my presentation was Teaching and Learning Relays. So even though some of the things that I suggest and show you pictures of may not be something that would be done in a service bay, I think it makes sense from an educational standpoint, and it's something I've proven out over the years when I've taught relays to students that gives them a better understanding and clarity on how this stuff works. For example, yesterday, here was the slide that we presented, and make sure that we know exactly the circuit that we're working on, et cetera, et cetera. And then we put an amp clamp around the fused link, or we hook our DVOM ammeter in series with the jumper lead. We're going to get a reading. That reading is the current draw of the device circuit, not just the device, but the entire circuit from B+ beginning to ground end. And my suggestion from a diagnostic standpoint was you can also go back to the device, wherever it is, blower motor, window motor, wiper motor, fuel pump, disconnect the connector from that device, run direct battery power from the battery back to the device and a dedicated ground, and measure the current flow at the device. And it should be the same as what you saw here. If it isn't, and it's greater there than here, it's telling you you have resistance somewhere in that circuit. Now, why did I suggest this test? Because it's easy to get to. You don't have to dig for wires to get your amp clamp around or hook your ammeter in series. It's an easy test, and it's a quick test to give you some indication, some diagnostic evidence as to whether you have a problem or not. It is the device circuit here that you're measuring the amperage flow of, not necessarily the device by itself. In order to do that, you would need to run a dedicated B+ and ground to the device, record the amperage there. Obviously, it should be the same. If it isn't, and this is lower at the receptacle, you have unwanted resistance, and then you start your surgery to find out where it is. You can do voltage drop testing, as someone said, et cetera, et cetera. Just when we talked about diodes in relays, and they said, well, why can't you use an ohm meter? You can use an ohm meter to determine if there's a diode in it. I'm not saying my way is the only way. I'm just suggesting this as other options that you may not have thought of. Would a technician pick this apart? Probably. But my feature here was to give you teaching tools with this PowerPoint to help you when you present relays to your students. And again, this is the exercise that we started yesterday. And one of the participants took issue with the fact that we're connecting a test light from positive to a positive source. That's stupid. Well, yeah, if you're a technician, that would be viewed as stupid. But I used this. I covered this in classroom with my students. We went through this exact same thing. I asked them to predict what the results would be. This is after we talked about relays, after we bench tested relays. Now we're looking at the circuit of the relay. And we went through this exercise. And the very next thing then, after they demonstrated competence, I gave them a car and I asked them to pick any relay they wanted, pull a wiring diagram for that circuit, and make these tests on the car. And because you're doing this test light in double polarity, you can really begin to see if they understand what they're doing or not. Obviously, in this case, the test light would be off because you connected a positive source test light with a positive source and nothing would happen. And of course, if we go to this way, the test light would be on if the ignition switch is turned on and if the fuse is good. Now, this gives you some diagnostic tests that are easily made at the receptacle or the socket that may take you some time if you tried to do it another way. I'm just wanted to, I'm not defending myself. I'm just trying to give you some explanation as to why I chose this strategy to present to you from a teaching standpoint, not necessarily from a service-paid technician. Hope you
So,
all
Dick,
understand.
Mr. Krieger, the room is basically agreeing with you at this point. So,
Okay.
yeah. So the folks in the chat are saying that it was perfectly clear, your point, and I think it's good that you revisited this. I think it's important to note the difference between education and industry. We have to teach bumper to bumper. We've got a lot to get to. We can't skip anything, and so if there's a fast, easy way, let's take it. Yeah, very good.
And one more point at this time. If you haven't muted your microphone, please do, because there's background noise.
Another point that we'll touch on a little later regarding the certificates, and I forgot to mention this at the beginning. We mentioned yesterday that in order for you to get a certificate, which you will get, you must click on that link that was included in the chat, which opened up the quiz. And the first question on the quiz was your email address. We're going to redo that today with a 2-question test. First is your email and second is your name. And in case those of you that only about half of the visitors yesterday took the test, which means only about half are going to get certificates. So if you're interested in an ASE towards your 20-hour training, you need to click on that link in the chat and get your email and name in here so we can send that certificate to you. The other thing I wanted to mention about that quiz, there should have been a schematic that was in that test. If you got the test without a schematic, it was probably because you were using a school computer and they may have blocked out all images that would be downloaded from an email or a link or whatever. But there should have been a schematic in that test that helped you answer the remaining questions down to number 10.
So, Dick, just to interrupt a second, I put a third question in there that shows an image, and I'm simply asking if you can see the image or not, because we're testing. So yeah. I put the link up there, and I'll shut up for now.
I know most of you got the image, got the schematic, and if you notice that schematic was a little different than this one, and had some of the weird, like 30 went to the fuel pump, and 87 went to B+. That is actually a GM fuel pump circuit that I used for that premise. So like I said, never assume that 85 is always ground and never assume that 30 is always B+, because it isn't. That's why you need factory vehicle specific service information before you start jumpering and testing and so on. So over here, we put the test light to 85. We connected it to positive. And the question was, what will the test light do? Well, 85 is the ground circuit. It's connected to positive. if we close the switch that the test light is on 85, if we close the switch that controls that relay coil, that test light should come on. That is a switch test. That actually provides us knowing that that circuit is good. And if we put the relay back in there and it still doesn't work, our chances are pretty good that we've got a defective relay or we're not getting power to 86. So this tests not only the circuit, but gives students an understanding of how this thing works, not just that the relay goes click. If we put the 85 to a negative source, nothing should happen. That test light will be off because we're on ground to ground. The second quiz that we didn't get to yesterday, now we are on 87, and 87 is connected to a positive source at the battery. And we look at the schematic and we see that 87 goes to the device. So now we have a test light connected to positive 287, which goes to the device, which then goes to ground. So now we've put the test light in series with the device. And depending on the resistance of the device, if it's greater or less than the resistance of the test light will either be on at full brilliance or dim, depending on the resistance of the load.
So Dick, you got a question in chat that you have to be, or a comment, you have to be careful if the ground is the ECU, may not light the test light.
That's true, except one of the premises that I had was make sure you have a test light of around 200 milliamps. That does two things for you. I've seen quad drivers turn the test light on easily, but it will not damage, it doesn't draw enough current to damage the quad driver circuit. Now, computers used to be a lot more sensitive and fragile than they are now. Most computers today have some type of current limiting resistors in there, and there's trouble codes that says overcurrent detected. But I've used a 194 bulb, and I've used most test lights today, unless they are deemed computer safe, will draw between 100 and 200 milliamps. Now, I've got a test light from my old days back in the 60s that draws almost an amp. It's one of those neon bulbs that are really bright. But today, most test lights that I've seen, and I'm developing a new class for Council Lab where we're having hands-on using a test light. I bought Harbor Freight because they were cheap. I bought 10 of them, and they all draw about 150, 160 milliamps. So it's a good point that was brought up. I agree with him, but I can tell you that I've never run into that issue with this test light series. So if we have a test light connected to ground to the load terminal, which is 87, nothing should happen. Now, if for some reason that light came on, it's telling us, excuse me, you have B plus somewhere shorted into that circuit where it shouldn't be. Two wires are cross-touching. There's something going on. That's why this is kind of a good diagnostic test. Now we're on 30. 30 on this particular circuit goes to B plus. We're on positive battery. Nothing's going to happen. If we go to ground to 30, we should get full brilliance if the fuse is good and if there is continuity between wherever B plus is sourced from to that terminal. So again, from a student understanding, we're asking them, do you understand what these 5 terminals do with the wires attached to them, how they go off into the car? That's the whole premise for this exercise. Could you turn flat rate doing this? Probably not. Okay.
Excuse me, is it okay to ask a question or not now?
Absolutely.
You know, when you had the test light from B plus at the battery 287.
Let me back up there.
From that's right, over to battery B plus.
Okay.
To battery B plus.
Battery B plus.
You know, am I correct in understanding that the gentleman's concern was that with the test light, that it would be drawing too much current, feeding it if 87 was going to a device in the computer or something?
No, I think his comment was on 86 or 85. If any one of the, in other words, if the coil is turned on by the computer, if there's a quad driver in the computer that turns the relay on, and we wanted to test the switching part of the PCM, his concern, as I understand it, was you want to make sure that the quad driver may not turn the test light on, giving you a false indication of a problem. I think that was, correct me if I'm wrong, but I think that's what he was asking.
And I presume that's because it wouldn't be drawing enough current to activate the light. Is that correct?
That is correct. But the quad driver, in my experience, has enough capacity to turn on 200 milliamps. Because if you remember, when we discussed the testing of relays, we said that the normal relay current for a coil is 160 milliamps. And the computer obviously is able to control that because that's what turns the coil on.
Okay, thank you for taking the time to answer.
Oh,
Thank you.
you're welcome. Anytime. All right.
Dick and Joe Hart, not necessarily about flat rate when you're trying to promote the understanding of circuits, and that's absolutely correct, I think.
Joe, I appreciate that, and please don't misunderstand my explanations. I wasn't trying to be defensive. I was just trying to explain, if that gentleman joined us today, which I doubt, why I did it this way. You certainly would approach this differently if you were an experienced technician working in a service bay. But this is for educators. This is giving you teaching tools that I've used over the years, and I'm willing to share them with you. That's all. Take them, throw them away if you want, or use them. Your choice. Okay, now we have a fused jumper wire, and this one has the full-size terminals on it. You'd have to make, another one for the smaller sized 5-pin and 4-pin relays, the micro 280s, as we've mentioned. And if I hook it across here, obviously what should happen? We know that we're hooked between 30, which is B plus, and 87, which is the device. We know that that device should be running when we make that connection. Now we have an ohm meter, and the ohm meter is going to be connected between 87 and ground. Why would we want to make that connection? It's just another way of doing the same thing we did with the test light. This will be a continuity check of the of the switch circuit of 80. I'm sorry, I'm mistaken. We've connected it to 87, which is the load. Now we're going to hook our ohm meter from ground to 87. That ohm meter will read the resistance of not only the circuit from that terminal back to the load, but the resistance of the load itself to ground. Is that a valid test? Well, you make that call. It will tell you if that circuit is open or not. If that meter reads infinity, even though 87 is supposed to be connected to the fuel pump or the blower motor, you got an open. Now you start surgery to find that open. It's just a quick and simple, is this circuit good or not? It doesn't tell you if it's good by the number of ohms of resistance. You can do that with voltage drops or amperage or whatever you want to do. Now, if I go to 85 and ground of my ohm meter, now this is the switch test using an ohm meter. We would energize the switch the same way we would normally. Now we're going to change the meter to milliamps. Now, your students have sometimes confusion when they use the ammeter portion of your DVOM. Look at this circuit carefully and tell me the student was doing what you thought he was told to do, and what's going to happen here when he hooks up a milliammeter between 85 and 86. Somebody answer in the chat.
It becomes
right.
dead short, becomes a dead short.
Someone says it becomes a dead short. And he's correct. You've
We have
connected-
some answers in the chat. Fry the fuse in the meter, lead in the wrong place, nothing good, no resistance.
all
Meter, let
all
smoke
correct
out.
answers. Yeah. And as you see, my representation is exactly that. Now, a student runs into the tool crib and grabs a meter because he wants to measure the current of the device that the relay controls. So now he's connected his meter between 30 and 87 because he's smart and he knows that that is the circuit between B plus and the device. What's going to happen here?
I got pop the meter fuse.
And that is the correct answer because he grabbed the meter,
Revoltage.
but he did not check the settings of the meter, and therefore it was set on milliamps from the last guy that used it. And of course, he will blow that fuse. That's why some meters require, now my Fluke, if I want to measure milliamps, I have to physically take the wire out of a socket and move it to the milliamp fuse socket. Not all meters are that way. But I'm kind of glad Fluke did that because there's a little beeper that turns on and says, Krieger, you forgot to move the lead before you can measure milliamps. And it won't let me measure amps unless I move that lead. So I'm sure you all have had students blow fuses on milliamp scales.
Dick, can I ask a question?
Absolutely.
You know, the milliamp versus the normal amp scale, I understand the meters are fused to about 10 amps. Is that to say there's actually a different lower rated fuse in the milliamp selection on the meter than there is in the amp selection? I'm just surprised that even though he had it on the milliamp scale, that he would blow the fuse as long as the circuit didn't draw over 10 amps. Why would he? I just don't understand why there would be a lower rating on a fuse in the milliamp circuit necessarily. The meter wouldn't just say out of range or something, would it?
No. It's been my experience that meters have either a milliamp fuse and no 10 amp fuse, or have a milliamp fuse and a 10 amp fuse. And, you know, the meter that we use on the Ohm's Law trainer, the CL19-1905, it has 1 milliamp fuse in it. It's rated at 200 milliamp quick fast blow. And yet the meter will read 10 amps. But if you look at the instruction for the meter in the manual, it says, and it's printed right on the meter, no more than 15 seconds of measuring 10 amps. They don't want things to heat up inside that meter. Now, a Fluke, a PDI, Snap-on, I think, has 2 fuses, a milliamp fuse and in my case, my Snap-on or my Fluke 88 has got a 20 amp fuse in it. My Fluke will measure 20 amps, but that fuse is expensive. So if you don't have a main fuse in your meter, I suggest installing a fuse in line with one of the test leads of your meter, and choose a fuse less than the expensive fuse in your Fluke meter or whichever one you have. That fuse will blow. Makes it a whole lot easier to change, and it's cheaper.
Once again, thanks for the answer.
Oh, you bet. Anytime. Okay. How many times have you diagnosed or tried to diagnose a problem, and whatever it is, brakes, electrical, you name it, and after you spend hours or minutes or whatever in diagnosis, you realize that a careful visual inspection would have originally discovered the problem? I'll raise my hand. I've done that so many times. I felt so stupid. So always do a physical inspection of not only the relay, but just your eyeballs are standing back and you're looking at things. And what am I looking for here? So in this case, we've taken the relay out of the socket. And as Russ mentioned the other day, GM does not want you rocking fuses back and forth because it will tend to enlarge the receptacle terminals of the socket. But if you lift it straight up and down, and by the way, they make special pliers now for pulling relays in and out is just they do the same with fuses. They make a special plier that clamps around the housing of the relay and pulls straight up. But my point here is visual inspection is very important. And of course, the wiggle test, and Russ said, GM says, don't do a wiggle test. I still do a wiggle test. I don't rock it back and forth a half an inch. But if there is a part-time connection problem due to corrosion or green or water intrusion or whatever, a wiggle test for both fuses and relays is a good diagnostic strategy, in my opinion. Swapping a relay, that is a very good process as long as you are 130% sure that the relay you're going to swap is the same relay as what you want to replace temporarily. You know, that's the old writing in the service manual, replace with a known good. Well, yeah, as long as the relay, and I've mentioned here in the last couple of days, there are differences between relays that look alike. And all I'm saying is don't grab one out of the PDC and plug into the relay you want to substitute unless you know absolutely for sure that they are identical. Just a caution. So I'm not saying don't swap. I'm saying do it with care. By the way, that high power relay, Bill Adams was saying he had one on his son's vehicle and it was like $25 for one relay. So make sure you know what you're doing there. Make sure relays are identical and that the swapped one also works properly. I can give you a case scenario years ago where a student swapped a relay and he swapped a bad one for a bad one, and he went off in a totally wrong direction because he didn't test the relay he was swapping with. So it's just common sense types of things to think about, that's all. Specialized tools. The full-blown PowerPoint and handout goes into much more detail on these, but these are simply some of the tools that are available online. Buy them from your tool truck, wherever. Lyle, you know, is a very common brand. X-Tech has got some good stuff. These are both relay testers and relay circuit testers. And I'm not saying they're bad. I don't particularly find the need of needing one myself because I'm able to do my testing at the socket the way I'd like to do. This is Snap-on and Max contribution. There's a set of those pliers I was telling you about that pulls relays out straight. This adapter right here, let me turn my pointer on. This adapter right here was taken from this set, or meaning number of sets. So what it is merely an extension of the relay socket. So it gives you 4 test points that are the same as the 4 socket terminals in the socket. If there was a 5-socket relay, the adapter would have 5 test points on it. So it raises up the relay. You plug the relay back into that adapter, and now you have a totally functioning circuit with test points. Not a bad idea. I just personally don't need them.
We've got a question, Dick. Can the ESI or X-Tech incorrectly bias a diode relay?
I got it.
We asked that question yesterday. And my answer is yes, it could, as long as if you're just plugging in a diode protected relay into that socket and you're not doing it in the way that the circuit is, you could blow up the diode. I personally don't have a lot of experience with these because I don't use them. I would hope that now understand, and I said this yesterday, diode suppressed relays are quite rare today. However, I do know that some cars still use them, especially in 280 micros. And that's because the circuit that relay is involved in is extremely sensitive. It's sensitive electronics, and they don't want any surge spikes at all. Remember, a resistor suppressed diode does reduce the spike. It doesn't do it as good as a diode does. So if you have an extremely sensitive circuit, they still use diode suppressed relays.
Dick, I just wanted to share a couple experiences I've had with your Lyle relay stackers.
Okay. Yep.
The first one, like on the back page you had before, looking at those terminals that stick out the top.
Yes.
I think is the green one that you had out of that kit. Yes. The two terminals that are close together are actually the control side. And I had a student come and put one in a Nissan Quest, and he jumped across there with a test light to see which one of the control was lit, and he jumped and shorted them and fried a $2,600 computer that we had to take to the dealer. And then in a couple of instruction things I've seen on the other side of the two loads, and they say you can do the jump there across instead of going from 30 to 87.
Right.
If you do that with a stacker in, it melts the stacker because that isn't designed to control current.
It's handle that much current. Yeah. That's a great point, and I have seen examples of that in other places. I will never badmouth anybody or any product, but I personally don't use these, but a lot of folks do, and they're probably a lot smarter than I am. But I want to be in control with fused stuff. When I make any connections to a relay socket, I want fuses to protect me from the what ifs.
Using School of Hard Knocks like that Nissan that the students tested, when it fries a computer that easily, you have to ask yourself.
Yes.
Mr. Krieger, we are at 2:32. I don't know if you are finished or nearing the finish line.
Let me finish this up. This is another tool that you may not be aware of. This is called the U-Activate from AES Wave. This is all in one tool. It gives you a current loop to put your ammeter on. It tells you which terminal 85 or 86 is ground or positive switch. It tells you which terminal 30 or 87 goes to the load. It's a great tool. Unfortunately, it's on national back order right now. But check it out. This will be in your PowerPoint. Please always use fuse jumpers whenever you're doing anything with a relay. And that should take us to the end. Make sure that you send me an email if you want these information that you see here, and also you'll get the correct answers for the plugging in the test light to the relay socket.
Okay, before everybody runs, let me stop the recording